Welcome to Karpado Learnings. In this tutorial, we're going to talk about web services. Specifically, we're going to focus on REST API or RESTful Web Services. We're also going to take a look at a sample application in the process. First of all, you need to understand why you should learn RESTful Web Services. One of the good reasons for that is it's a must-know architectural style because pretty much all the applications that are built nowadays does use REST API in one or the other form, and it's an absolute must for you to learn REST API for interviews because REST API is such concept that you must be able to answer in interviews. And moreover, industry is moving towards microservices. How do these microservices communicate each other? Is by using REST API. So that's yet another reason for you to learn. What are the goals of this tutorial? The primary goal of this tutorial is to give you some good understanding of RESTful Web Services. We'll also demonstrate REST API by creating a sample CRUD application. And above all, I'll try to make you feel comfortable answering questions related to web services. Here is the high-level view of what we're going to cover in this tutorial. Maybe you'd like to pause the video and take a look at this entire list. After you finish watching this tutorial, or while watching this tutorial, if you have any questions or suggestions, do let me know in the comments. I'll try to respond with all the questions. You can also suggest me a topic for my next tutorial. One thing that I should mention is it's very easy to get distracted while watching video. So if you want to have better learning experience, then try to avoid all the distractions like mobile phone notifications or Facebook, etc. Just stay focused on this video till the end, and you will learn a new skill. Good luck. Before we dive into understanding web services, it might be a good idea to understand traditional monolithic MVC applications. If you already know about them, that's great. Otherwise, here is a simple scenario. Imagine that I have a company and we provide weather forecasting services. Now, whenever somebody visits our website, out of many features, they're going to see a button that says Show Current Temperature. When the user clicks on this button, they would be shown with the current temperature depending on the user's location. Well, behind the scenes, this is how it works. As soon as the user clicks the button, a HTTP request will be sent from the browser to the server. The underlying container will then forward that request to a relevant controller. Controller will delegate that call to model. This is where we would have the business logic interacting with the database, etc. And in our case, we're going to figure out the current temperature in model section. And then after that, from within the model, we're going to send back the response, basically an object that would constitute the data back to the controller. Controller will then handle that data to some view technology, depending on the view technologies that you use. For example, if you're using JSP, the JSP would consume that data and JSP file would be converted into equivalent servlet file, which will have a bunch of println statements. And then ultimately, that servlet would be executed and the response would be sent back with the HTML back to the client. And so user will see the response. And in this case, we're assuming that our application is residing in a single server. There are certain challenges with traditional monolithic applications. Let's talk about a few of them. Imagine that there is another company who are providing flight booking services, so their customers can book flights, etc. What they found out is that they also needed some weather information depending on which they would schedule flights. At the same time, they don't want to spend a lot of money hiring people to develop that service for them. Instead, what they want to do is to use our service by paying a certain amount. So they will approach us and we talk about a deal, and finally we agree with a contract to use our service. From that point on, what they will do is they will send HTTP requests from their application, from their business logic, to our service to extract the weather information. But our application is designed in such a way we won't be sending the data, but we'll send data along with the HTML or the presentation logic. This is clearly a problem. The flight booking service is expecting our service to send data but we're not only sending data but also the presentation logic. This is bad for two good reasons. Number one, the flight booking service does not have knowledge on how to understand HTML. So they have to introduce some additional modules or write additional code to chop off all the HTML tags and extract the data from it. And another problem is, even if they're able to do so, presentation logic will not remain same. It will keep changing. So when we make changes in our HTML code, it's also going to break their code, and so their application will not function as well. So this is one problem. Another problem is, if you think about a website like Amazon, you can't expect Amazon to be hosted on a single server. I mean, what if there are not enough resources to handle the traffic? Or what if the server runs out of disk space? Or what if there is a bug in the app? That's going to cause the entire application to crash and no one would be able to access the website. So instead, their application is split up into multiple components, and each component would be residing in an independent instance of server, and each instance would handle a particular task, especially with microservice architecture. And when you split up the application in this manner, they often need to communicate each other in order to perform a business task. But unfortunately, the way we're deploying our applications, they won't be able to talk to each other because we're not sending the data, we're communicating with data with presentation, and that's not feasible at all. So this is clearly a problem. Another problem arises when you talk about single-page applications. If you don't know about single-page application, here is the simplest definition of the same. A single-page application is an application that does not need a page reload when the user is interacting with the application or the website. Here are some of the examples of single-page applications. Let's talk about Gmail, for instance. The moment you log into Gmail, you're going to see all the email subjects, and when you click on one of those subjects, all the content would come up. But the page reload does not happen as soon as you click the subject. Similarly with the Google Docs, when you're navigating through the entire Google Docs application, it does not cause page to be reloaded. Only that particular section which you wanted to access would be populated. Twitter is also a single page application. You can click on multiple links that are available in Twitter and use all its features without causing page to be reloaded. Same is the case with Instagram. The moment you click on image, it does not cause page to be reloaded. Same is the case with Netflix. There are many such examples, including Facebook. Facebook is also partially single page application. And basically it's not about page not getting reloaded. The idea is that it will improve the performance of the application and gives a better user experience. Single page applications are possible because of the way it works. Whenever user visits the website, a GET request would be sent to the server. Server would then respond back with all the HTML, CSS, JavaScript, etc. And from that point on, for all the user interactions with that website, the server would only send back the data without the presentation logic, because server has already injected the JavaScript, which is a client code essentially, like Angular, React, or Vue.js, which is handling the presentation part by taking the data. Anyway, that's a topic of future, but I hope you understood how single page application is working. But with our traditional monolithic application, server is going to just respond back with HTML, making single page applications harder to implement. So this is clearly yet another problem. We will take a look at how we can bring solutions to these problems, with of course web services. One of the solutions to our problems is remote method invocation, or simply RMI. Basically the idea is that you would no longer send the HTTP request and then receive HTML as the response. You're going to directly call the method inside the model layer. In other words, you're going to call the business method directly that is residing in another JVM and get back the data as the response, basically whatever that method returns. Going back to our flight booking service example, the flight booking service would now be able to call the getTemperature method along with parameters. In this case, it's going to send the location to the remote method residing in another JVM, which is our weather forecast service. And then the remote server is going to respond back with the data or whatever the value that the method returns, which will then be used inside the flight booking service. This is possible with RMI. Using an RMI tool, we're going to create so-called a stub and a skeleton. Stub is going to reside on the client side, which in this case is flight booking service, and the skeleton is going to reside on the server side, the weather forecast service. From within the client application, you would use the stub object and you would be able to call the remote method. Internally, stub will take care of establishing the connection with the server and then send those parameters to the remote machine. The skeleton on the other end is going to receive those parameters, call a specific JVM method or the remote method, and whatever the method returns, the skeleton is going to send back the data or the object back to the stub, and stub will then forward it back to the client application. In simple terms, the client application or the flight booking service would interact with the stub as if it is interacting with the remote object. Well, RMI makes it possible to exchange data between services, but it has its own drawbacks. For instance, since we're using RMI, it will only work with Java, so only if the two applications are deployed on JVM machine and they are both developed using Java, they both can communicate. If, for example, you would like to interact with a PHP application, then it's not possible. So this is a significant disadvantage when you're talking about distributed applications like Amazon, where all the services may be residing in various geographical locations on various different platforms and might be written in various different programming languages. They all need to be communicating with each other in order to perform a business task. But with RMI, their application is only restricted to use only Java and use JVM platform. So that's definitely a drawback. Another drawback is, of course, you won't be able to interact with technologies like Angular, React, or Vue because these are all essentially JavaScript libraries residing in the client, and you cannot just talk to them using RMI. Along with all these, there are certain other disadvantages with RMI. I mean, it's not efficient and the code doesn't look so user-friendly to developers. And for that reason, RMI is not even an option nowadays. There are better alternatives, which we'll talk about in a while. Okay, let's talk about web services with SOAP protocol. We've seen that two services, which may be written on two different languages or technologies, and may be running on two different platforms, cannot actually talk to each other because they just cannot call a remote Java method when your application is written using, say, PHP or .NET technologies. So the underlying problem is we don't have a common language that these two entities can understand. If we can introduce a language that these two entities can understand and exchange data between them, that would solve our problem. So the language of choice is XML markup language. XML is just a bunch of tags, somewhat like HTML, and we can define our own standards. And at a very high level, this is how it's going to work. Going back to our example on flight booking service, where it tries to access the weather forecast service to maybe extract the current temperature depending on the location. Assuming that the flight booking service or the client is written using PHP or .NET technologies, and it tries to access a remote method of Java, which is residing on a different host or a remote machine, this is how it's going to work. You as a developer of PHP, you're going to use a PHP library in order to send the request. So you would send the parameters or the method name, etc. And this underlying library will take care of converting that request into equivalent XML file, which will then be transmitted over the internet to the remote machine. On the remote side, you would have a library written using Java, which will take care of parsing all the XML data and making a call to the Java method. And whatever the value that the Java method returns would again be wrapped inside XML tags and would be transmitted over the internet back to the client, which will again be received by the library and would be translated back to technology-specific implementation. So ultimately, you'll be able to make a call to a remote method, which was written using different technology than to that of the client, and you'll be able to receive the data as a response back to the client. Now, in this case, the weather forecast service is called a web service because it is essentially a service available over the web, and somebody can access it over the internet, like the flight booking service is trying to access it. But we still have a lot of problems here. I mean, you can't just send any random XML and expect the remote machine to understand it. You have to follow certain standards, or you have to follow certain standard tags in order to exchange data. And all these entities who want to be part of the web services would stick to that standard. And that standard is nothing but SOAP, or Simple Object Access Protocol, which are just a bunch of rules that needs to be followed by all these entities in order to exchange data. In simple terms, it's a messaging protocol, a standardized way of exchanging data using XML between these entities or services. In addition to all this, the client also needs to know how to access the web service, what are the method parameters that are expected, what is the written value that it can expect, etc. We have to use WSDL, or Web Service Description Language, in order to define all those stuff. So here is the rough format of a SOAP message. It's the same format which you need to follow for both request and response. You would have to have the root tag, which is envelope. It's mandatory to start your XML with this tag. And when I say you have to start, you don't really have to do that as a developer. This will all be taken care by the underlying library. You don't get to create the request XML in this format unless you're testing. So you need to have the envelope as the root tag. It would have typically a bunch of child tags, the first of which is an optional header tag, wherein you could include some authentication information. This is optional. And you need to have a mandatory body tag. This is where you would include all the information required to call the remote procedure or to send back the response. In our flight booking service, if you were to send the request from the flight booking service to the remote method, the body would include the information to call the remote procedure, including the parameters that you want to send. So maybe you would want to call get current temperature and you would pass string as a parameter, then you can do so. In this case, what we're looking at is the response received back from the web service back to the client. So here we're trying to send the name of the location and the current temperature that it is trying to return. But still, this is not the complete SOAP architecture. It is way more complex than this, and this is just a very high level view of how it's going to work. In case if you're curious how it exactly works, in case of Spring WS or Spring Web Services, here are the sequence of steps you need to take care in order to create a web service and expose it over the internet. You would first create so-called an XSD file, and it looks something like this, and this would define the information about the parameters expected, the expected written value, etc. So you have this get temperature request, for instance, and you're expecting to receive location as a parameter to the remote method, which is of type string. And similarly, you're going to send back the response, which is the temperature in the form of string. And using this XML document, we're going to use a tool called JAXB, which will be a Maven plugin or Gradle plugin depending on the project management tool you're using. We use this plugin in order to create domain objects using this XSD file. This will be done with that plugin. And then we'll create an endpoint, which is essentially a place where you would receive the request and process it, kind of like a controller, and it would sort of respond back with some return value. And inside here we would use all those domain objects. And then finally, Spring WS will create so-called a WSDL file that I talked about using this XSD file, and would make it available over the internet. On the other end, whoever wants to consume this service, like in our case, flight booking service willing to consume the weather forecast service, we will again use the JAXB plugin in order to create the domain classes using the WSDL file that was published over the internet, and then using those request and response domain classes, we would send the request and receive the response. Well, this is at a very high level. Down the line, we'll have some examples that we'll understand even better. So in the end, we may have all these advantages by creating web services with SOAP protocol. The first of which is interoperability, meaning that Regardless of the technology using which your service is written, every service can actually talk to each other using SOAP protocol and exchange data between them, like the scenario that we've just talked. The second of which is SOAP uses HTTP protocol, and hence there won't be any issue with the firewall. Going back to our RPC example, for instance, or remote procedural call, you have to open a secondary port, and oftentimes firewall may actually block that traffic. So with SOAP, since we're using HTTP protocol in order to transmit the data, there's going to be no problem with the firewall because HTTP port is always open and firewall will not stop it. In other words, the message that I talked about would be wrapped with the HTTP header and body. Inside the body would have this message. SOAP also works with other protocols like FTP, SMTP, or TCP in order to communicate within the network. And for this very reason, for all the advantages that I talked about, SOAP is a better alternative compared to RPC when it comes to single page applications or distributed systems. Well, that being said, there are a lot of disadvantages when you're trying to access web services with SOAP protocol, and we'll talk about them once after we cover REST architecture. Let's talk about RESTful Web Services. In order to understand what is a RESTful web service, well, here is the definition defining what is a RESTful web service. A service which is built on REST architecture is called a RESTful web service. Now, obviously, this may not make complete sense to you because there are a lot of terminologies and principles that you should be aware of in order to understand what exactly is REST architecture. By the way, REST stands for Representational State Transfer, and we'll understand it as well in coming slides. The first term that you need to know is something called a resource. Now, there are a lot of definitions to define what is a resource in RESTful architecture, but according to me, I want to put it very simple. You can think of resource as something that you can manipulate with a URL. For example, a resource can be a document which can be viewed over the internet with a URL, or it could also be a row in a database which you can manipulate with URL. If you're not exposed to web services, this might sound strange that you'll be able to manipulate a database record with a URL, but that's what REST is meant for. In RESTful Web Services, even a record in a database is termed as a resource because you can manipulate it with a URL, an example of which can be seen in here. Assuming that you are having a school management application, for instance, and let's say that you'd like to retrieve all the students available in the database, for which you would use a URL that looks something like this. You'd say whatever is the domain and then /students. This request would land in a controller logic which will have a URL mapping that maps with this URL pattern, and it would delegate that call to business logic or whatever. Ultimately, it would retrieve all the students in the form of either XML or JSON. The data would look something like this if it is in JSON, and then would be sent back to the client. It is up to the client. Depending on the client, it could be a server, it could be a JavaScript technology, etc. Whatever it is, ultimately it's going to consume that data and do whatever it wants to do. Another example is, let's say you wanted to access a specific record of a student by passing the identifier. So in this case, we're trying to retrieve a student having the following ID, and the server would respond back, or the web service would respond back with the following JSON data. Likewise, inside web services, you would be able to seek all the services offered by a web service with URL. Let's talk about RESTful methods. RESTful Web Services relies on HTTP methods, so you can pretty much use all the standard HTTP methods in order to manipulate with a resource. For example, you could use HTTP GET method like we did earlier in order to access or get a resource from the server, or you could use the POST method in order to create a resource on the server. You can use PUT in order to update a resource on the server, or delete in order to delete a record in the server or resource in the server. For example, if you'd like to delete a student record, you'd pretty much send the same request but using a delete method instead of get method. And obviously, as you might have guessed, we can't use these methods from the browser because browser would only support get and post methods. We would have some additional tools to do that job for us. For example, we have a Chrome plugin called Postman, or you can do it from a tool like curl. Here are some of the other elements in RESTful architecture that we should be aware of. We have request headers. This is where you would include authorization and authentication information, because in most cases you don't want web services to be accessible by everyone. There has to be some kind of authentication or authorization. Maybe I want to expose my web service to only paid audience who have the credentials. So this is where you would include those authorization and authentication details so that my service can provide services to you or the client. The request body is something where you would include the data, or you would essentially include a representation of a resource in order to perform some operation. For example, you may have a data that looks something like this, and you're going to use a post method of HTTP in order to send the request. So that way this student entry will be stored as a record in the database. Now this brings me to talk about what is REST. REST stands for Representational State Transfer. What that means is when you're trying to retrieve the student information, the record that is present in the database is represented in the form of JSON or XML, whichever the client requests. So that is essentially representation of a state of a particular object residing on the server, and you're transferring it from the server to the client in a format that a normal human can understand. And then you have response body. When you fire a GET request, you're going to get back with some response, typically in the form of XML or JSON. All this information would be part of the HTTP response body, and that's what this means. And in RESTful architecture, we would use the HTTP status codes in order to show the status. For example, if you're able to retrieve a record from the server, then you're going to see 200 OK status of HTTP. Similarly, if you're able to update or put a record using post method, then you'll be able to see 201 created as a status. And if your authorization and authentication is invalid, then you may see this error code 401 unauthorized. Now I'm pretty sure that if you're a beginner of web services, all this may sound a little complicated, but actually it isn't. Once we take a look at an example in future, you would definitely be able to connect the dots and understand what's happening. Well, REST is not any standard. Like for example, if you're talking about SOAP, there is a particular format of a message. In case of REST, you don't have to follow any standards. But that being said, it's necessary that you need to follow these principles if you want your web services to be a RESTful web service. If you break these principles, you can, but it is you who will pay the price. So it's always better that you follow these principles if you want to leverage the benefits of RESTful architecture. The first of which is something called stateless, which means server or the web service should not keep any client information, because a web service is publicly available over the internet and many clients can send requests to it. If the server stores all the client information to maintain the conversational state, that's going to cause a lot of resource drain. So it's necessary in RESTful architecture, every request that comes from the client should be treated as a brand new request, even if the previous request had come just a moment ago. And it's the responsibility of the client to provide all the necessary information in order to process the request. The second principle is so-called caching, which means the client must be able to store the retrieved data or cache the retrieved data. What that means is, let's say I sent a GET request and I got back with some response from the server. I should be able to store that information in the client machine so that if client sends the same request again, the request doesn't have to go all the way to the server, but instead can be retrieved from within the client itself. And of course, server can configure how much time should the response be cached, etc. The third principle is called a layered system. What this simply means is your web service should be able to split up into multiple modules and they can be residing on multiple servers. But from the client perspective, it has to send requests to only one entity and shouldn't be bothered about all the different entities. So essentially, client doesn't have to bother about how the web service is managed on the server end. It just has to be able to send a request with a URL. The fourth principle is so-called uniform contract. This is actually a combination of multiple other principles, and the first of which is identification of resource, which we've already talked about. A resource must be identified with a URL. That's what this means. And then we have resource manipulation through representation. When you're trying to store a record or update an existing record, you're essentially manipulating a resource with the representation. You're going to send a JSON data in order to manipulate a resource on the server side. That's what this says. Next of which is self-descriptive message, and is something that we had already talked about. It just simply means that the client has to provide all the required information in order for server to process the request. Next we have hypermedia as engine of application state, or simply HTOS. Well, to put it simply, whenever client sends a request, the response from this server must have enough information to let the client take further actions. We're going to take a look at a quick example of it in next slide, and then you'll understand better. Next we have client server, which just simply means server will not care about the presentation logic, so it doesn't care about how your data is presented, etc. And at the same time, client does not have to take care of storing the data. It's the responsibility of the web service. So here is a quick example of hypermedia as the engine of application state. When we get into examples, we'll understand this even better, but here is what it is roughly. So whenever you're trying to say retrieve the account information of a person based on the account number, you're not only going to get how much is the balance left, but the server has also responded with a bunch of links using which the client can take action. For example, using this URL, you can deposit some money, or using this, you can withdraw some money, or transfer or close. But then if you don't have enough funds, or if your balance is in negative, then you shouldn't be prompted with other links apart from the deposit, because when your funds are negative, you should not be able to transfer money or withdraw money. And that's why those links should not be shown. Well, this is what is HTOS essentially. So when you have a RESTful web service that follows all these principles, you can say that your architecture is a RESTful architecture and your web service is a RESTful web service. Now you might be wondering, what is the real difference between SOAP and RESTful web services? Well, you cannot really compare REST with SOAP, because SOAP is a protocol, it's a messaging protocol, while REST is an architectural style. In fact, you can use SOAP protocol inside the RESTful architecture as well. But again, maybe you would be limited with only XML data. But what we can compare though is we can compare RESTful web services with SOAP-based web services. So here are some of the differences. So REST is an architectural style, SOAP is a protocol. SOAP is based on XML, and REST would support multiple other formats like JSON, XML, plain text, etc. In fact, the client application can ask server what kind of data it is expecting, and based on that, web service will respond back with the data. It could be JSON, XML, or plain text. Similarly, REST exposes API with URL mapping, while SOAP uses annotations. REST works with JavaScript technologies like Angular, Vue.js, React, etc. compared to SOAP. One of the good reasons for that is representation of data in JSON format, which is native to JavaScript. And since there is no overhead of using XML in order to wrap the data, REST requires very fewer resources compared to SOAP-based architecture. And moreover, REST responses can be cached by the client, and SOAP will not support caching. Overall, REST is clearly a winner compared to RMI or SOAP, and would allow us to have distributed applications, and client can be anyone who want to seek the data from the web service. And not to mention, it is perfect option for single page applications and distributed applications. Here is the architecture of traditional Spring MVC application. Initially, the client or the browser would send the request to the server. Server will take a look at the web.xml file in order to determine the front controller or the dispatcher servlet. Now it is up to the dispatcher servlet to determine the relevant controller where it needs to delegate the call to, and for that it will take a look at the handler mappings that we configure. A handler mapping is nothing but a mapping between a URL pattern with a specific servlet or the controller. The controller will then delegate the call to the model. This is where you would have services, repositories, or model objects. The goal of model is to take the input, process it, and then respond back to the controller with the data or the model object. The controller will then handle the model object along with the name of the view back to the dispatcher servlet. The dispatcher servlet will take a look at the view resolver in order to determine the extension of the view. In case if you're using JSP for instance, the extension would be .jsp. The dispatcher servlet would append that extension to the view name and then forward or give that data or the model object to that view in order for it to render. In case of JSP, the JSP would be translated into equivalent servlet, which will have a bunch of println statements with HTML tags, and ultimately the server would execute this servlet and respond back the HTML back to the client, which will be rendered on the browser. In case of web services though, we're going to get rid of all this view part because we're only interested in sending back the data. So instead of sending back the HTML as a response, we're going to send the data as part of the HTTP response. And not to mention that since we're using Spring Boot, majority of these are auto-configured. When I say we have to configure handler mapping, we really don't have to because it's all taken care automatically. You don't even have to configure the dispatcher servlet or web.xml file. Pretty much everything is taken care by Spring Boot auto configuration, and we can just focus on things that matter. In our example application, the client can be anything. It could be a mobile application, or it could be a desktop application, a web application, or another application running on another server. They will fire HTTP request to our REST API. So here is where our application would be running, and the job of our API is to respond back with data in the form of JSON or XML. It is up to the client what they do with that data. But since we don't have any of these clients at the moment, we don't have any client applications like AngularJS or Android app, we're going to use a tool called Postman that will allow us to test our API. And in this chapter we'll perform all the CRUD operations so that we can understand how we can leverage HTTP GET, POST, DELETE and PUT methods in order to manipulate a resource or the data. Hope it makes sense. As I was mentioning before, web services is all about making use of HTTP methods like GET, POST, DELETE, etc. Unfortunately, browser is not the best tool in order to test our application because browser is only capable of sending GET and POST requests. If you want to be able to use other HTTP methods, you either have to have an application that is capable of sending such requests, or you should be installing a tool like Postman, which will help us do that. Postman is a great tool. It's free for personal use, and you can just download and install it just as you would install any other software. Or if you're using Chrome, you have a Postman plugin, but in the recent past they are claiming that their browser plugin is deprecated and they are recommending us to download their application. You can download it real quick and install it. We will test our application with this tool. Let's take a look at the API that we're trying to build. Assuming that our application is about e-commerce application, one of the modules of e-commerce application is to be able to manage product details. So we're going to expose a product API, and somebody can actually manipulate with the resources by using following URL patterns along with HTTP methods. If somebody sends a request to product using get, they must be able to see all the list of products. If somebody sends a get request with an identifier as a path variable, then they must be able to see details of a specific product with that specific ID. And if we send a post request to the same URL along with request parameters, then we should be able to create a product. And in case if we wanted to update an existing product, we would use the put method to do the same. And in our API, we're going to accept JSON as the input in order to update a resource. And finally, we will perform the delete operation using the HTTP delete method. So we will be able to delete a specific product with a specific ID, and the ID would be passed as a path variable. Hope it makes sense. Alright, it's time to create our first REST API using Spring Boot. I hope you're excited. I'm assuming that you have installed Eclipse and Spring Toolsuite already. So with that in mind, I'm going to click on the File menu, click on Other, search for Spring, and I'm going to click Spring Starter Project. We've talked about all these already. So in my case, these are the values that I had entered. I'm going to change the artifact name to Spring REST API. The only module that we'll be needing is Spring Starter Web, because if you hover your mouse over there, you can see that it will help us build RESTful Web Services. However, if you're building SOAP Web Services, then you'll be needing this module. And we could actually include a database like H2 embedded database, but I want to keep things simple for now, and we're not going to use any database for the time being. So I'm going to hit finish. It's going to take a while for Spring Toolsuite to create the project and sort of import it into our Eclipse environment. You can see the progress in bottom right corner. Alright, once you have it ready, we're going to be needing few packages. So I'm going to expand source main Java, and inside here I'm going to create a package to keep all our controllers. And in this case, we're just going to have one controller, and whatever the traffic that we get from the dispatcher servlet, we will receive it in our controller. So that's going to be controller. We're also going to be needing another package to store our services. So this is where you would have your business logic. We're going to dependency inject these objects into our controller in order to manipulate with the data. So this is going to be a service layer. And we're also going to be needing model although we're not going to interact with database, we're still going to create a model, because this is the same object we're going to use as a command object in order to map the request parameters, etc. You will see in a while what I mean. And that's it. We have everything in place to get started creating our REST API. Ideally, we're supposed to include one more layer, which is repository, but since we're not using database, I'm going to ignore it for now. Hope it makes sense. The first functionality that we're going to introduce is to expose an API to retrieve all the products available. Let's first create a controller specific for product related requests. I'm going to call it as product controller in camel case, and we want to receive requests that has /product in their URL. So I'm going to introduce a request mapping annotation with the following pattern. In addition to that, I'm also going to make this class a REST controller. This is similar to a controller annotation. The only difference is this time this controller is tuned to respond back with the data and make it part of the HTTP response. Now this is complete opposite to traditional MVC applications where the intent is to respond back with HTML, in which case the controller will respond back with model and view objects. If you hover your mouse on this annotation, you can see all the annotations that will make this annotation. So we have controller as well as the response body. So whatever the data that we want to send would be part of the response body. The next thing I'm going to do is to introduce a method to retrieve all the products available. But before that, we need to have a command object. So I'm going to create a product class inside the model, something like a Pojo. In case if we had a database, this would be our model, so we would have all those annotations to map this particular entity with the relational database table. But at the moment we don't have a database, but still we're going to use this as a command object in order to store the product related data. This is going to have 3 variables in my case. One is product ID, and then we have a string which is going to be product name. I'm going to introduce one more field which is an integer, and that's going to represent the product price. I'm also going to introduce a couple of constructors, and for this I can make use of Eclipse to do the job for us. I'm going to introduce a no-arg constructor, and I want to make this private because we don't want to be able to create instances of this class. But since we're going to use this as a Pojo or an object that holds the data of products, we do need a parameterized constructor. I'm going to make it public. So if you want to be able to create an instance, that's only possible by sending the parameters. You can't just create an empty instance. And of course we're also going to add getters and setters. I'll do Ctrl+Shift+F to give proper indentation for our code, just to make it look visually better. So now we have the model object. The next thing is to introduce the service layer. This is where we would have our business logic. Before creating the class, let's create the contract, which is an interface with set of methods. I'm going to call it as product service. So in our case, I'm going to return a list of products, get products. It doesn't need any parameters. Ctrl+Shift+O to import all the missing classes and interfaces. And then I'm also going to create a class product service implementation, and that's going to implement product service. Let's also add all the missing unimplemented methods. So I'm just simply going to create a list of products and then return that list. Array list of products. Products dot add new product identifier as the long. Let's call it iPhone as the first product, and its price is going to be, say, $999. Well, actually, I guess nowadays it's more expensive. Let's make it $1,999. I would add a couple of more products, give a unique identifier. We're doing all this because we don't have a database, and this is going to be, say, a speaker, which is of, say, $599, and then we have maybe a book, which is, say, $99, and return all the products inside the controller. Well, before that, let's make this a service because we want this to be auto discoverable with Spring's auto scanning. So the Spring will configure this bean by itself. Let's now dependency inject this product service inside our controller. Control-Shift-O, auto wiring. Now let's introduce the method, which is pretty much going to have the same signature. So I'm just going to copy it over here. And this is just going to respond back with all the list of products available. We also want to annotate this method as get mapping because we want it to receive all the get requests from the client. And of course we want to return them. A couple of things to note here is that the request mapping annotation doesn't correspond to any specific HTTP method. So all the requests or all the URLs that has that particular string in them would end up in this controller. And inside this controller we have methods specific to HTTP methods. In this case, we're trying to map with all the GET requests. So if we send a GET request with this particular string in the URL, the request would end up in this method. Also, REST controller annotation comes with response body. So you don't have to declare response body annotation in all the methods in this class. So that's another advantage of using the REST controller annotation. And I guess with this, we have everything in place to test our application. Let's run our application. If you've created the project using Spring Tool Suite, you should be able to locate this file. Just run it, just as you would run any other Java program. We don't have any errors. Let's open the Postman application. If you're using Postman for the first time, you may be feeling a little intimidated looking at the interface. It looks very complicated, but trust me, it's very user-friendly interface. Only thing is that it will take a while for you to get used to. So as we progress through this course, I'm going to talk about various features that this tool has to offer, and thereby you'll feel comfortable using this tool by yourself. So can you guess what should be the URL here? It's going to be localhost 8080. That's where our server is running, and product. Let's send the request, but before that, do make sure that you choose get as the method. And see, it did work. Here are the list of products returned in JSON format. The next thing that we're going to do is to have the ability to fetch a specific record or specific product information. So first let me introduce the interface method for our product service. The method is going to take long ID as the parameter. This would correspond to the product ID and is going to respond back with that specific product if it is available. Let's go to the service implementation and provide the behavior. and here we have it. What we have here is we're trying to search a specific product in the list of products. Now this is all core Java. I don't think I have to walk you through this code. But here we have an error because we're trying to access a list that is not scoped within the class. So let's move this list out of the method and put it over here at class level. However, we still have a problem because the list won't be populated unless we first request all the list of products. So let's make this code as part of the constructor. I'm going to create a constructor real quick. And let's populate the list. Control-Shift-O, Control-Shift-F, and there you have it. And inside the controller, we already have the service dependency injected. I'm just going to introduce another method, but this time we have something called a path variable, because from the client we should be able to send the identifier. Let me correct this real quick. And that's it. So if you want to fetch a specific product detail, then in addition to having this particular URL mapping, you should also provide the identifier. Let's relaunch our application and see how it works. So I have the exact same request, but this time I'm going to append the identifier. Let's say I want to fetch details of iPhone, so I would say 1, and it has retrieved the information of that specific product. Let's take a look at how we can create a resource with post request. First, let's create a method in our interface, and here it is. It's not going to return anything, but it's going to take in these parameters which will help us create a product. And here is the implementation for the same. All I'm trying to do is to add a new product by taking in all those arguments. And inside our controller, I'm going to introduce a method with post mapping. So all the HTTP post requests would end up in here. This method is going to take in 3 parameters, and these are essentially the request parameters that we would send from the client. This is as good as receiving the form entered data from the client. And all we're trying to do here is to create a product. We're just calling one of the service methods in order to create a resource. In addition to that, we also want to send some status back to the client so that the user would be aware that the resource has been created. So for that, I've created a map with string as the key and object as the value. I'm trying to populate one of the map elements, which I'm sending back as the response. And all these map entries, in this case it's just one, would be rendered as a JSON response on the client machine. So let's take a look at how we can send post request from our client. So this time I'm going to choose post, and I'm going to go to body tab and click on form data. So this is essentially going to simulate submitting a form from the browser. So we need to send these parameters ID, name and price with the exact same name. ID, name and price. ID is going to be a unique value. I'll say 4. Name is going to be maybe washing machine or whatever. Price some random number. Let's try sending the request. Okay, we seem to be having problem because we're trying to append this parameter. Let's get rid of it and send the request once again. Oops, I completely forgot the fact that we need to restart our application. Sorry about that, and let's go back and send the request once again, and this time it worked pretty well. So that's how you would send a post request. In our next example, we'll take a look at how we can send JSON as an input as part of the request. Let's take a look at how we can perform an update of an existing resource. I'm going to introduce a method inside our interface, and this is going to accept product as the method argument. Let's also provide the implementation, and all I'm trying to do here is I'm trying to find the product with the specific ID and trying to update its fields in this manner. Again, this is all core Java. Let's go to our controller, and this time we're going to introduce put mapping annotation because we're going to use the HTTP put method in order to perform updation. And here is something new. We're trying to use this annotation request body because this time I'm not interested in sending request parameters like we did in case of post, but instead I would like to send JSON as part of the request body. So by specifying this annotation, the JSON body would be mapped or would be binding to this object in here. So ultimately the JSON would be converted into product, which we'll use in our code. And I'm also returning the same object, which will be rendered back in the form of JSON or whatever the client requests. Well, the tricky part is how do you send the JSON data from the client? Let's take a look. So I have to send request using this URL, but this time it's going to be put HTTP method. But before that, let me make use of the get method to extract all the product information. I haven't started my application, and so you're seeing that error. Let me quickly copy this. Control C. Let's say that I wanted to update this particular product, iPhone. Maybe I wanted to change the name to something else. So I just copied it. Let's go to put method. Click on the raw to enter the raw JSON. I'm just going to paste in whatever I had copied. And I want to name this as maybe my phone or whatever. Let me add one more line. And let's send the request. We seem to have a problem when it says content type plain text not supported. Okay, the problem is we're trying to send this as a plain text, while on the other end it is expecting JSON. So let's select the content type as JSON and try to send it again. And this time it worked. The field has been updated. Let me do get request again and see if it has indeed updated. Sure enough, it did. Let's take a look at the delete operation as well. Delete operation is pretty straightforward. So we're going to have a method that's going to accept the identifier, based on which we need to find the specific element and delete it. And here is the implementation that does that job. I'm trying to remove an element from the list, and I'm making use of the one of the methods that we've written, get product by ID. This is going to return the product, which will get deleted ultimately. Inside the controller, the code is pretty straightforward. We're just going to accept one path variable. Based on that, we're going to delete a specific resource. And again, in order to show some status, we're just populating this map and returning it. Let's test our application. So this time I'm going to use delete. Before that, let me get all the list of products available. Let's say I want to delete product with ID 1. Delete, and I'm going to send 1 as a parameter, and item got deleted. Let's try to verify it, and sure enough, it got deleted.